Hello everyone. In this video we're going to begin talking about chapter 3, which is describing and visualizing two variables together. So what we'll see is we will first talk about two categorical variables together. So how do we look at, describe, and display two categorical variables together? Then we'll look at two quantitative variables. And then we're going to talk about predicting the outcome of a variable based on another one. And that is a major section of statistics called linear regression. We won't look at it for very long, but if you continue on to take Stats 2, that's the main focus of that course. Okay? And then we'll also possibly mention at the end, what if we want to look at a categorical and a quantitative variable together? We talked about that a little bit near the end of the last chapter, but we can do it again here. So we're going to first start off with the terms that we need when we're talking about two variables together. Okay? So we need to distinguish between what's called the explanatory and the response variable. Now, many of you come from different backgrounds academically, meaning some of you come from the hard sciences, some of you come from what they call the soft sciences, so on and so forth. And all of those fields are looking at two or more variables together, but they may have different words that they call them. So they may not call them the explanatory and the response, but that's what we're going to use in the sort of statistics world that we live in right now. So the explanatory response is what we'd often call the X variable. So most of the time we're going to be looking at these variables and relationships on the Cartesian coordinate system, or the XY plane as you often know it. Okay, we're going to explain, so why is it called explanatory? We're looking to explain the behavior of the response with the explanatory variable. Okay, so one thing that we'll talk about right at the beginning, because it's two categorical variables, are the classic example of smoking and lung cancer. Okay, so can we link those two in any way? Is there what we'll call an association between smoking and lung cancer? Can I explain how likely people are to get lung cancer based on whether or not they smoke? Okay, is there any sort of effect there? So that's the explanatory. The response is the outcome variable, or the Y variable. It's the outcome variable on which comparisons are made for different values of the explanatory variable. Okay, so it's the response, of what we see based on the value of an explanatory variable. Okay, so that's theoretically sort of what it is. Then another term that I used already is an association. So an association between two variables, and that's the wrong two, there should be a W there, exists if for particular values of one variable are more likely to occur than with certain values of the other variable. So what does that mean? If you again think of the smoking and lung cancer relationship, you would expect that more people who smoke would have lung cancer at least proportionally than people who don't smoke. Okay? And so for particular values of one variable, smoking, for whether you smoke or not, are more likely to, lung cancer are more likely to occur with certain values, smoking, of the other variable. So there are the terms. Let's start by looking at the association between two categorical variables. So when I view two categorical variables together, the sort of device or graphical thing that we use to look at them, or rather their numbers, is called a contingency table. So what is a contingency table? What is it? What does it look like? So a contingency table cross-tabulates the occurrences of each variable in conjunction. Okay, so what does it look like? It looks like this, okay? And so for each For some of you, it may look like a matrix if you are a math major, okay? And it sort of acts like a matrix. If you look at the cell, so for instance, 68 here, okay, is the first cell, and it represents that in this study where they collected people's hair and eye color, 68 people had black hair and brown eyes. Okay, down here, 119 had brown hair and brown eyes. Okay, down here, 94 had blonde hair and blue eyes. Okay, so it counts the number of instances that occur with both black and brown happening. Okay, so that's a contingency table. So what can we do with contingency tables? Well, we can look at their association based on proportions. Okay, so when I'm looking at categorical variables, I'm often going to base my decisions or my ideas based on proportions. And proportions are just the numbers, the counts that we have divided by the whole. Okay, the whole meaning all of the numbers added together. Okay. A marginal proportion is a proportion of the whole for a particular category of one variable. So for instance, what do I mean? If I ask you, what's the proportion of respondents who had black hair? I can gain that information from the contingency table, and what I would do is add up the numbers that are in the black row. Okay, so the first row, I'd add up 68, 20, 15, and 5, and divide it by the total number of people who were asked these questions, which in this case is 592. So it would be 108, 68 plus 20 plus 15 plus 5. It's that first row. Is 108. 108 divided by 592 is 0.812, or 18.2% of people had black hair who responded to the survey. Okay, the proportion is like a percent divided by 100, so 0.812. A conditional proportion, and this is an especially important one, is the proportion of one category based on the value of, proportion of a category of one variable based on the value or given the value of another variable. So what does that kind of look like as a question? Well, I could be interested in the proportion of those people who have blonde hair given that they have blue eyes. Okay, so what's the proportion of people who have blonde hair given that they have blue eyes? And so when I condition on the value of another variable, and when I mean condition, I say given is the key word here. Given that I already know that this person has blue eyes, what's the proportion of people who have blonde hair? So instead of looking at the whole table, I only look at the blue eyes column, which is the second column, okay? And I divide how many people have blonde hair and blue eyes, 94, divided by the marginal proportion or the marginal total of blue eyes. Not the whole thing, just blue eyes, because I already know that they have blue eyes. So that would be 94. They are divided by 215, as if you add those together, 43%. Okay, and so this should maybe make some sense to you because blonde hair and blue eyes do sort of go together. Okay, so that's a conditional proportion, and that can be especially interesting to us. Okay, when explaining a relationship. So here's the first your turn. So this is an example of a classical data set that asked people their education level, okay, or assessed their education level, and they assessed it at either low, medium, or high, and then also asked them what are their views or what they were asked in some way whether they support abortion in some case. It wasn't an in like support abortion in general. It was support abortion in some case, or maybe you can think of sort of right to choose there. Okay, but I just called it abortion. So some sort of view on abortion and educational level. So when you're reading this and it says like positive, they did not ask people like, do you like abortion? And then they got the data from that. That's not what happened. It was something much more complicated that I'm sort of boiling down here. So don't take too much into account into the actual variables. This is just a exercise in making proportions. Okay, so I ask 3 questions. The first one is a marginal distribution question. Then I ask what's called number 3 is a conditional proportion question, and then number 2 is just a joint proportional question. Okay, there's no like margining. You don't have to look at the margins of the table. You don't have to look at marginal proportions or conditional proportions. It's like a straight proportions question for number 2 there. Okay, so that's the your turn and the end of the video.